Yeah, hey Tom, it's Roger. Hey, I'm just going to sort of let this thing fly. I know you know virtually everything that I know about this kind of chemistry, so I'm going to sort of shoot right through this. But as I told you before, I believe I have soft tissue fossils, and I believe they have bodily fluids, or at least something we can test for the presence of life. Now, whoops, this where were we here? This is into the area where we have the lungs. And this is these triangular pieces, they're all over the place, and they turn into crystals. And that's apparently how the lung works. And I can show you some very specific structures of this. But this black, the black is, can be ferrous. There's two ferrous oxides. There's the I forget the numbers, but there's Fe2 and Fe3. One of them turns black and one of them turns red and once they oxidize. And you can see we have two different oxidations there. So I believe that's what's going on there. Now, this is the same stuff, but a little less degraded. And I have them in all variations of degradation. I mean, I have them so that they're like almost like, well, I actually do have them with blood in them. Anyway, you'll see in a second. But this is the kind that is the lung structure, and I'm pretty sure what I'm talking about. Now, I think I sent you this already. That's the scab that comes out of the blood foramen, and if you can look and see this material that's around there. Hold on. This material here is what is called fascia. And you see these little flaky fibrin fabrics in here? That's the keratins that make a protective layer between this and the rest of the body, or the rest of the bone, and periosteum, or whatever's in between there. I'm not sure what layer this is at, but actually this would probably be on the periosteum, or if it has a facial layer above that, a synovial sheath or something like that, I'm not sure. Anyway, inside here was the two foramen cavities. Okay, we're looking at that. Okay, that's the fibrin, white, flaky fibrin stuff that is the clotting fabric that's just natural in blood clots. And when it came away from that, we had that. Now this right here, if you remember this one, this is the, those two holes are the vein and the artery. And as we talk, the artery, as I told you, I believe the artery purges during when the gas is off all the body fluids and things, and it purges everything. It just blows it out from internal pressures. Now, this one over here, you see that drainage ditch there? This one leaked afterwards, and it does this after it's entombed in the ground. Originally, apparently, I mean, this is just speculation, but I'm pretty sure we can prove this chemically. Anyway, let's just go on from here. These are the two, as we talked about, the vein and the artery, and I say that the vein leaks because of the venal clamps that seal it off, and then once it changes in pH, and everything is related to pH on this, and I have a paper on this about it. And once you get, and it's because of being in a volcanic area where the pH level has gone low. And once you get in the low pH level, the iron in the blood, and the blood becomes absorptive. This is how the body uses it. You go below 5.0 and it becomes, it can become soluble and be able to be absorbed by the body. But if you go above into the alkaline range, it doesn't. But once you originally hit it with the acid and it goes into that, they call it chelation. Anyway, you know, you're going to know all about this stuff. Just all I need to know is does this have DNA in it? But I want you to realize what I'm talking about is reality here. This stuff was alive at one time, and it's being denied as being alive. And I believe that right there, that's not mud. I believe those are blood cells. And that, because that came from deep inside of a tiny little lung. And I mean, as I remember I told you, they are decaying down to a point where the crystallization is almost complete to unbelievable levels. And you know, this right here, that is not a beehive or anything. That right there is the cellular structure of a lung. And I have them in every different degree of degradation. And this is metals found inside the fabric of the lung. And it's all of the metals, exactly what it says in the chemistry, they're all here. And here it is as the little blood vessels turn into crystals. And garnets are blood. That's what I found, garnets are blood. And here this is gold. This gold is, I don't know if it's gold or not, but I say it is, and it looks like gold, and it doesn't display the characteristics of what do you call it, that? Fool's gold. And it's in crystal, and this is coming right out of a lung. That is the exit of a lung. These here are, like I say, that's once you rechelate it or dechelate, I can't remember. I haven't played around with this for a while, but this is what I'm getting. These are organic tissues, and I'm sure there's going to be something in there that you should be able to get at pretty easy. If you look at that, now you see all those little fabric flakes in there, all these little white triangular looking things, they're in every single lung.